Hello, this is Rob again. Welcome to Business Calculus section 5.5. And today we're going to continue our discussion about integrating, but this time we're going to integrate um, between two graphs and find the area between two graphs. We'll also look at consumer and producer surpluses and some real life problems. So again, the main bulk of this is to find the area of a region bounded by or between two graphs. So we're going to be finding points of intersections with these two graphs and still use our integrals the same way we've been doing in section 5.3 and 5.4 with one small modification. We're going to take the upper function and subtract out the lower function. The definition that we're going to be using here is the area between. And this kind of does a nice job of explaining it because the area of f of x, if this is the f function, if we look at it, the area of everything below this, and then if you subtract out the area below the g at x function, all we're going to be left with is the area between the curves. So it kind of makes sense to take f at x and subtract g sub x, because we're just taking this entire distance and subtracting out this smaller piece, and that'll leave us with the area between. So once again, this is a long mumbo jumbo for how we find the area between. Take the upper function and subtract off the lower function. Sometimes it's f of x minus g of x, sometimes it's g sub x minus f of x, but it's always the upper function minus the lower function. So this is the definition we're going to be using today. I could even clip this, and I think we have our first example coming up next. So I'll paste that right here. So again, all I need to do is figure out where maybe some points of intersections are and which one is the upper function and which one is the lower function. So I think this is a parabola, this is a line. If you were to graph these really quickly, I know this one's starting up 2 units, so it's a parabola going this direction, and this is that y equals x function. So I can see that the upper function is going to be the y, x squared plus 2, and the lower function is going to be x. So I'll say the integral of the upper function, x squared plus 2, minus the lower function, minus x. And I'm going to integrate that between, well, they tell me between 0 and 1. So I'm going to rewrite this just a little bit. This is really x squared minus x plus 2 integrated between 0 and 1. Integrate means to increase, so we're going to increase this exponent 2 to a 3 and divide by that value. This says increase this exponent 1 by 1 and get 2, divide by that number. And then if I integrate the 2, I end up with 2x, and I'm going to evaluate that f of b minus f of a. So if you plug in, here's my a term down on the bottom, here's my b term. So f of b, I'm going to plug in a 1 first. 1 cubed is 1. So here comes my f of b minus f of a. Here's my f of b term. Here comes my f of a term. And let's see, let's plug in a 1. 1 times 1 times 1 is 1, 1/3, minus 1/2, plus 2 more, minus, and I'm going to throw in some zeros. Well, if you throw in a 0, that's okay, 0 divided by 3, 0 divided by 2, and it's not very interesting. It's a whopping 0. So really it's just 1/3 plus 1/2 plus 2. Looks like I messed up on a sign right here. It should be should have been 1/2, excuse me, 1/3 minus, because of this minus sign. I'm going to get lazy. I'm going to pull up my calculator and look at this. 1/3 minus 0.5 plus 2. I'll change that to a fraction. It looks like it's going to be 11/6 for the fraction form. I could go decimal, but again, I'll be rounding, so I like the exact answers. Moving on, for the second example, the first thing I need to determine again is which is the upper and which is the lower. I notice that this is a negative x squared. It's coming down, where this is that y equals x. So again, it looks like the upper function is my 2 minus x squared. The lower function is x. If I and I'm going to integrate that. Well, they didn't tell me what to integrate it from, so I'll have to find these points of intersection. On the first example, they told me what the point of intersections were. Um, on this one, I'll have to try to locate these points of intersection. So to do that, we just set the two functions equal to each other, or you could go to your calculator and graph them and find points of intersections. But I think it might be easiest just to set these two functions equal to each other, because that's going to help me locate points of intersection. If I add x squared to both sides and subtract off of 2, looks like I can factor this thing. Duh. Let's try to write a little bit neater in here so you can see what's going on. So this becomes what? X plus 2 and x minus 1. So it looks like the points of intersections might be at x equals -2 and x equals 1. If you let x be -2, well, the y value equals the x value. You could plug it into this one as well, but it looks easiest to plug it into here. So it looks like maybe the points of intersections are -2, -2, and possibly a 1, 1. So it looks like I'm going to be integrating from low to high, -2 up to 1. So I'll write that over here. I'm going to integrate from -2 up to 1. You could reorganize this. I kind of like the x squared for terms first, but I'll just go ahead and integrate here. This is going to be x cubed, the negative stays up front, divided by 3. I'm going to do this term next. This is going to be negative x squared divided by 2, and this will be a positive 2x for this guy, increasing by 1, but I'm still integrating between -2 and 1. So I'm going to use my calculator, and I'm going to plug in a 1 and do my f of b minus f of a. Again, I'm going to cheat and use my calculator here a little bit. So the f of b term would be, let's see, I'm going to plug in a 1. 1 times 1 times 1, that's going to remain -1/3. This will plug in a 1. I'll get 1 squared. This will be a -1/2. And if I plug in a 1 here, I'll get +2. I'm going to take that entire answer and subtract everything in parentheses. And this time I'm going to plug in the -2 to every term and subtract off every term. So let's do the -2 cubed is -8, but I have another negative out. So how about positive 8/3? If I plug in a -2 here, it becomes positive 4 divided by 2 is a well, it's negative though, so I'm going to say minus 2, because I got a 4 in the numerator and a 2, and then minus 4, because this is 2 times the -2, so minus 4. We'll let my calculator do the number crunch, and I get 4.5. If that was a long stringy decimal, I would hit math, enter, and try to convert that to a nice fraction. But 4.5 or 9/2, either way is working for me. Since the last problem was in fraction form, I'll go fraction form here. And the author did 9/2 as well. All right, so moving on, find the area bounded between this function. It looks like a parabola again, but this time it's the x-axis is one of the functions. So again, a quick little graph of this. I know it's a parabola shoved 4 units down. It might be shifted left or right as well, but I know something's going on, such as this. I need to find out, again, points of intersection. So I'm going to set this function equal to 0 and try to find points of intersection, because I got to figure out where to integrate from. And again, remember, I want the area below, so that would be this blue area down in here. To find points of intersections, again, factors of 4 that differ by 3. How about 4 and 1? Signs are going to be different. The larger is negative, so x minus and x plus, and it looks like my roots are at -1 and 4. I could label these points -1 and 4, but again, I just want to integrate between, looks like -1 to 4 of x squared minus 3x minus 4. Of course, there's always a dx on here, which I've dropped from the last couple problems. Technically, I should be writing. And I actually want to do, I don't want to forget my definition that I'm learning today. I want to do the upper function minus the lower function. It looks like the upper function is the x-axis. So I really should modify this a little bit. The equation of the x-axis is actually y equals 0. So I really should be doing 0, the upper function, minus the lower function. And so now that changes my integration just a little bit. Now I'm integrating from -1 to 4 of negative x squared plus 3x plus 4. Let's see what we can do to integrate this. Increase this by 1, divide by that exponent, increase this by 1. Who is that? 3 halves x squared and plus 4x. And again, I'm going to go to my calculator and do some number crunching. F of b minus the f of a. I'll see if the author has done this just for sake of time. Oh, good. They integrated the same way we did. Good. So moving on, did they do it? There it is. F of b minus f of a. Number crunch that and see if you don't get 125/6. Good. So the area of the region bounded by two graphs, we're doing the upper minus the lower. Ooh, here we go once again. I guess a couple things when you approach a problem. You got to figure out which is the upper, which is the lower. A quick little sketch of the graph is always helpful. You might want to graph these in your graphing calculator so you can see what's going on. And you got to find points of intersection by setting these equal to each other. So before we cheat too much, let's go ahead and at least find the points of intersection by hand. I know you can do that on the calculator as well, but it's not too bad to set these two functions equal to each other and find points of intersection. We'll see if we can do it here. If not, we'll go to the calculator and find. I'll show you how to find points of intersection on the calculator. So if you add x squared, hey, if you add x squareds, it looks like those terms are canceling here. This is canceling with this. That's nice. If you subtract off the 2x, I think we're getting 3x cubed minus 12x set equal to 0. And from here, I can factor out a 3x, leaving me with x squared minus 4, my favorite topic. You can factor some more because this guy factors to who? Difference of two squares, x plus 2, x minus 2. And don't forget, you do have a factor here as well. And we know that that factor is set equal to 0. 3x equals 0 when x is 0. Here, x is -2, and here, x is +2. So it looks like I have 3 points of intersection here. Again, looking at a quick graph, I can find all 3 points of intersections, 1, 2, 3, and it looks like I'm going to have to do the area between the x value -2 to 0. I'll integrate this as one function. Notice that this is my upper function here, where the f at x function is above the g at x function, so I'll have to treat this as two separate problems. So there's the upper function minus the lower function, and then I'm going to have to find this area, but notice this time I'm doing the g at x function, the upper function minus the lower function. So again, two problems in one. We're going to have to break this up. The upper function minus the lower function could be written like this. So here's the first problem from doing the upper function minus the lower function. I'll get that 3x cubed minus 12x. But over here, if I do the g sub x minus the f of x, I get the -3x cubed plus 12x. So again, the author has integrated this for us. Remember, this is only between -2 and 0, where this one is being integrated from 0 to 2. Again, the reason behind that is because I have two problems in one. I'm finding the area for this purple section and then finding the area for the blue section. So with some massive number crunching again, evaluating, again, we're doing f of b minus f of a, and the f of b is not too hard because that should be a 0. So really, this is going to be f of b minus f of a. Don't forget, it's 0 minus all of this. So watch out for your negative signs. But it looks like the author has done it for us. Here it is, 0 minus all of this is where we left off on the last slide. So there's my f of b minus f of a, and I'm going to add it to this next section, f of b minus f of a, and evidently we get 24. So please try that on your own and email me with any questions. Thank you.